Hey guys, welcome to another one. So number 7. So here we need to find the first three terms in ascending powers of x of the binomial expansion of 2 minus x over 2 all to the power 7, given each term in its simplest form. This is very easy, honestly. This is very standard. But if you're not sure how to do binomial expansion, I would really recommend you learn this formula here. This is the formula I adapted and pretty much made it general. Because if you're actually deciding to do the A level instead, well, unfortunately, if you're doing AS, you can only do AS. But if you're doing for A level, you could use this one adapted for the second paper. Anyway, let's have a go and understand what's happening. So we're given 2 minus x over 2. The key idea firstly is to make it 1 plus or 1 minus at least. So 1 needs to be important here. To do this, we need to factorize the 2 outside the bracket. So let's go ahead and do it over here, yeah? If we're going to take 2 out, well, and because it's a power 7, we take 2 to the power 7 out, meaning inside we're left with 1 minus, and if we take 2 out of here, we'll be left with x over 4. That makes sense, because 2 times x over 4 gives us x over 2. And all of this to the power of 7. So far so good. So now this part here looks a bit like the 1 plus ax term, where you got 1 is 1, and now you got minus a quarter, which is a, and you got x, and n is 7. Now all you do is literally just plug this into the formula. So we can say, okay, therefore, and just stick in 2 to the power 7 in front of it for later calculation. We can say that the binomial expansion is going to be 1 plus, and instead of n, we're going to have 7. So 7 over 1, which is 7. Ax, so a is going to be literally minus quarter x, or we can copy the whole thing, minus x over 4 to the power 1. And that's it. Plus, and then we do the second term. We've got n times n minus 1, so we've got 7 and then 1 back, so 7 times 6. Over 2 factorial because there's 2 terms, and then same thing, minus x over 4 all squared, and so on. If we had more terms, we'll carry on. Yeah guys, and that's really it. So now that you've already solved this, all you do is expand it carefully, multiplying each term as it is, and when you do that, you should get this, literally simple as that. 128 minus 224x plus 168x squared. And you can just write plus dot dot dot, indicating that of course it goes on for more terms, but we just want the first 3 terms, and voila. Now B, let's finish this off here. Explain how you would use your expansion to give an estimate for the value of 1.995 to the power 7. Well, you just have to use your answer here to pretty much work that out. So this is our expansion we need. But what it means is that, first things first, when you look at this figure, you need to notice that this figure here is kind of similar to the original expansion here, the original bracket, before it's expanded. They both got power 7 actually, and the only difference is the inside term. They kept it algebraic and they actually gave you a number here. So all you essentially need to do is really say, okay, let's equal this and find the correct x value to give you this. So what I did, I equated them. I said let 2 minus x over 2 equal 1.995, and I solved for x and got 0.01. Now all you do for x is literally plug it back into this equation, and when you do that, you're going to get some estimate of this one up until for the first 3 terms. So just literally plug in your x value into this equation. So it looks like this. So 128 minus 224, instead of x, 0.01 plus 168, 0.01 squared. Okay, have a go, you guys, and I'm going to quickly just do it right now actually. So I should get 128 minus 224 answer plus 168 answer squared. Oof. So I got, okay, that's what I got. How many decimal places? Alright, so actually the calculator is fixed. You get 4 decimal places. So I got 125.7768. That's it. All done. Yeah, so far guys, as usual, if you're enjoying this video, please give me a like and subscribe, and give me some feedback if there's anything else that's not clear or you want me to teach in a slightly different way. I'm all ears, so just let me know, yeah. But yeah, other than that, let's move on to 8. So let's check it out. Okay, so it looks like a nice triangle question. So before we even read this, I think we should just work out this extra angle here. So we know all angles in a triangle adds up to 180. Got 60 and 70 makes 130, meaning we've got 50 left here. Okay, and they seem to give us one length of 30. Now let's read the question. So triangle lawn is modeled by the triangle ABC, okay, and the length AB, which is the bottom here, is 30 meters long. So given that we know the 2 angles, calculate the area of the lawn to 3 significant figures. So to find the area of the lawn, which is basically a triangle, always use this formula, which is the half AB sine C. This is literally the area of the triangle, and I always picture it like this. If this was side A and this was side B, then angle C is in between. It's always the angle between A and B. So suppose we got this angle here, we should just find one more length. If we found this length here on the left side, then we pretty much have an angle between two lengths. Now to do that, to find any of these angles, I would use the sine rule, because you can take the relationship between the ratios of the length and the angle and solve. So let's go ahead and call this length x, yeah? So to find the relationship, we could say, okay, and the sine rule looks a bit like this. It's always some length over a over the angle of itself, opposite angle, equals the length b over the sine of its opposite angle. So let's go ahead and use it then, yeah? So let's use x and sine 60 because they're opposite. So we can get x over sine 60 must be equal to another pair. So 30 over sine 50. Okay, easy stuff. And then just solve for x. So just times sine 60 across. So you got 30 over sine 50. Oh yeah, be very careful. Make sure your calculator is in degrees mode, yeah? So always in degrees mode. I don't know, it depends on each calculator, but there should be an option to switch out radians if you have it on that. But if you don't know what I'm talking about, then your calculator is probably nice and fine. But yeah, so for x, I got exactly, well, roughly 33.92. So keep it into 2 decimals or 3, or leave it unrounded if you can. And then now you got this length. So if we redraw a triangle, we can say, okay, we got 70 between two lengths, x and 30. So x is 33.92 and 30. And now we just plug into the formula here. So we could say we've got half AB sine C, we've got half times 33.92 times 30 sine 70. So doing that, half times answer times 30 sine 70, and you should get to three significant figures, 478. What's the unit? Meter squared. Yeah, it can't be centimeter because it's actually a garden. Yeah. So for part B, so why is your answer unlikely to be accurate to the nearest square meter? So this is one of those thinking questions. Now, logically speaking, and I've checked the math scheme to just confirm this, sometimes you don't have to necessarily answer the actual square meter, because the general idea is to put this in a real context. So this is talking about a 2D map of a lawn. Now, if you think about it, if you look in your garden, there's probably a good chance that your garden isn't 2D, so it isn't flat. And it's probably going to be a bit bumpy and might have a few hills or whatnot. So the area actually might not be correct. This is the area on the baseline, but the area could be a lot greater because there might be a greater surface area or higher hedging. So you could say, for example, as the math scheme would say, that the land or the lawn itself is not flat. So you could just simply say not flat. You know, various other reasons around it, just by the shape of it being not entirely 2D. Another answer that they also suggested was 4 significant figures. Now this one, just what it really means is that your figures, that if we calculate it properly or incorrectly even, we won't actually get the correct 3 significant figures, or even so, it's unlikely to be exact, as they might grow or the hedges might grow. But either way, I think the best answer for this one is to just look at the shape and just wonder, realistically, in the current situation, would our garden be 2D in this form? That's it. Anyway guys, yeah, I hope you guys enjoyed this video and this little explanations. If there's anything else you want to add to, especially part B, let me know in the comment section. If you enjoyed this video, please give me a nice big like. And yeah, share with your friends, your mates, your buddies, everyone. And yeah, otherwise I shall see you in the next question.